everyone, and thank you for joining us today. It's my pleasure to introduce Eugene Rubanov to present batch data to graphs, integrated Neo4j and Flink via JDBC. Over to you. Thank you.
Thank you, Kostya. Hello everyone. My name is Eugene. I'm a software developer at Neo4j and work in connectors team. Today I want to talk about one way of connecting Apache Flink and Neo4j. I will provide a few code examples and discuss when you can apply this approach. So first of all, what is Apache Flink? Apache Flink is an open source framework for processing data streams. It is designed to handle both unbound and bound streams, and it provides APIs at different level of abstraction. The most widely used are the data stream API and table API. Flink includes a wide range of connectors for integrating with third-party systems, usually data stores and messages queues. However, there is no currently out-of-box connector for Neo4j. So the approach I want to demonstrate will utilize JDBC. I'll focus on implementing async for bounded streams. But the same approach theoretically can be adopted to export data from Neo4j or import data from infinite streams as well. The key ingredients for me would be the Flink JDBC connector and Neo4j JDBC driver. So the Flink JDBC connector provides both a source and a sink using the JDBC API. It supports bounded sources and both unbounded and bounded sinks. It also takes responsibility for managing connections and patches, and it implements both data stream API and table API. However, today I will be focusing only on data stream API. Neo4j JDBC driver is a standalone product. It's not based on Java JDBC driver, so it gives a little bit more flexibility in how it can be used. It adheres to JDBC 4.3, and it natively supports Cypher. However, optionally, it supports SQL to Cypher translation as well, which means theoretically you don't have to know Cypher to use JDBC driver. And it doesn't have its own connection pools and integrates with other pools and managers, which again, very flexible. So let's take a look at the code. So the first thing we need to do is to configure JDBC driver. So the configuration is very typical, very standard. We need to set the driver class, JDBC URL, and credentials to Neo4j database. After that, we actually can define our job. So here is an example of a single node import. So the first of all, we need to create an instance of stream execution environment. This is an entry point for building and running any Flink job. Then we create a data source that produces a stream of product object. This could come from a file, a database, or another system. So it's basically where the data starts flowing from. When it's done, we actually can define how we will be writing to Neo4j. So in this case, I'm using Cypher. So I'm defining a Cypher query and a function that will be used to copy fields value from our object to prepared statement. And when it's done, we assemble everything into a sink. So you might notice two more configuration options here. One is the batch size, meaning that the prepared statements that will be generated by JDBC connector will group records by 500. And the second option is at least once delivery guarantee. It basically means that the records might be written more than once. After that, when we have our sync, we can link source and sync together and execute our job. Importing relationships is very similar. The only different part here is the Cypher query. In some cases, not knowing Cypher can be a limitation. In such situation, it's perfectly fine to use SQL instead. The Neo4j JDBC driver includes an optional SQL translation feature enabled by enable SQL translation property. When this property is set, the driver attempts to convert SQL queries to Cypher using a chain of translators. The default translators are included in the full driver bundle, but the chain can be customized. Once the property is set, we can use SQL statements to write records. For nodes, the table name will be converted to a node label, and the property and the column names will be converted to properties. For relationships, it's slightly more complicated. The translator can infer the start and end node labels and the relationship type from the synthetic table name, provided that you use standard naming conventions. If not, you can define your own naming pattern with JDBC property in the form of regular expression. You also can use labels, node labels as a namespace for properties to help SQL translator generate proper Cypher and attribute the property to correct object. Okay. What are our limitations? So JDBC driver requires Java 11 or later. So that's our first limitation. Because of that, it's best to use Flink 2.1, which actually supports Java 17. However, theoretically, you can use Flink 1 starting from version 1.18. It actually introduced Java 17 support in the experimental mode. The next limitation is this approach is only for data stream API. Table API supports only a limited set of databases, and Neo4j is not one of them. Fortunately, the data stream API is flexible enough for such integration as ours. The only supported delivery guarantee is at least once. That's because Flink connector achieves exactly one guarantee by running queries in distributed transactions, and Neo4j doesn't support distributed transactions. In practice, this means that duplicate records are possible. One way of handle this would be introducing a schema and using merge statements to actually handle the duplicates. And the next problem is because Flink works with stream abstraction, there is no straightforward way to manage dependencies and order between between streams, partitions, and nodes and relationships. You have to control the import order yourself to prevent conflicts like deadlocks during the relationship import or importing the relationships before related nodes. For bounded streams, the simplest way would be to achieve that would be to split the import into several independent jobs, each handling individual independent part of the data. SQL translation. Another problem is SQL translation feature supports only a limited subset of SQL statements. Some queries may not be translated correctly to Cypher. It partially can be mitigated by implementing your own translator, but it's a bit difficult. It doesn't quite support multiple labels because each label represented as a table name, and there is no one-to-one kind of mapping between those two entities. I probably recommend reviewing JDBC driver documentation first if you decide to use SQL, or you can always use native Cypher. And the final limitation I want to mention is this approach doesn't manage the database schema automatically. You'll need to run your own scripts to ensure Neo4j has all required indexes and constraints. So in the result, this approach is fully viable. However, it's not plug and play. You'll need to write some code to define your sync logic, split the import into several jobs, and handle schema setup, tune SQL Cypher statements. But with a bit of development, it offers a flexible and maintainable way to move data between Flink and Neo4j. That's all for me for now. If you're interested, feel free to try an example. You can see the link on the screen right now. Also visit Neo4j JDBC repository, and you can find link to documentation there as well. Thank you for your attention. I would be happy to answer questions if you have any. There's not much questions, not many questions, so that's probably it. Thank you again. Thank you for attention, and enjoy the notes. Bye.